Now we'll talk about Isosceles triangle theorem. So to be able to use this theorem, you have to have an isosceles triangle. So remember, an isosceles triangle is a triangle where it has two sides that are equal. Okay, so let's say that this side had the same length as that side. So to show that, remember, we put our little tick marks. Okay, and so what this theorem says is that if you have an isosceles triangle, then what's called the base angles are equal. Okay, so let me label this triangle. So let's say that that is angle A, B, and C. Okay, so well then what are your base angles? Well, your base angles are the angles that are opposite of these congruent sides. So think of like an angle like a mouth, okay? So like if you think about this angle right here, angle A, it's like a mouth. It's kind of opening up. And so the side that it opens up to is the side that's opposite of it. So notice angle A opens up to this side right here, okay? So angle A, notice, is opposite of one of your congruent sides. And so the other angle, the other base angle in that problem would actually be angle C, because notice angle C opens up to the other congruent sides. So what this theorem says is that if you have an isosceles triangle, then the base angles are congruent, meaning they have the same measure. So the angles that are opposite of those congruent sides will also have the same measure. So whatever this angle is will actually be the same as that one, okay? So your base angles are congruent. And so one thing I do want you to realize is, remember, they can turn these triangles around. So don't always think that the base angles are going to be at the bottom. That's the reason why I'm talking about make sure you realize they're the ones across from the congruent sides. So like in this problem, angle A would be congruent to angle C. And so whatever the measure of angle A is will actually be the exact same or equal to the measure of angle C. Okay, so that's what that theorem says. So let's do some problems where you have to use that theorem. Okay, so when you're looking at a triangle, if they show you that two sides are equal, you automatically know that the angles that are opposite of them will be equal to each other. So when I look at this triangle, notice it says that we have to find the measure of angle B, and we also have to find the measure of angle C. One of these angles I can find super quick just by knowing that theorem, because if I look at this triangle, angle A is across from one of my congruent sides. The other angle that's across from the congruent side is actually angle C. So I actually know angle A and angle C are congruent. So angle C would actually have the same measure as angle A. So angle C, right off the bat, I know is 50 degrees. Okay, so now how do I find angle B? Well, if you think about the other theorem that we talked about, remember, all the angles in a triangle have to add to be 180. So if I add these all up, it should equal 180. So you can actually figure that out pretty quickly, because you can kind of add these up and subtract it from 180, and you'll find out how much is left. So if I take 50 plus 50, that's 100. And if I take 180 and subtract 100 from it, I'll know how much is left for that angle up there, which ends up being 80 degrees. So angle B is 80 degrees. And so notice my base angles are equal, and then I found that one just by knowing that all the angles have to add to be 180. Okay, so then what if they give you a problem like this? Well, notice they're not just asking you to find the angle measures anymore, they're actually asking you to find x. So when that happens, you have to use what you know about these angles. And so notice, if you look at this triangle, it is an isosceles triangle. And so one thing that I know is that the angles that are opposite of those equal sides will be equal. So if you notice, this angle right here is opposite of that side. This angle is opposite of that side. These are the sides that are congruent. So I know that those two angles are congruent. which means that they are equal. So to be able to find x, I have to set up an equation. And if I know they're equal, I'm going to take one of my angles, and it doesn't really matter which one you do first. I'll just start with this one. I have to take one of my angles and set it equal, so you put an equal sign to the other angle. Okay, so now that you have your equation, you're going to have to solve it. So because we have variables on both sides of my equal sign, I got to get them together. And so to move on the other or the opposite side of the equal sign, I have to do the opposite. So I'm actually going to move my 6x over. So I'm going to subtract 6x because you have to do the opposite, and you got to do it to both sides. So these will go away, and I'll be left with negative 36 on this side, and then 4x minus 6x ends up being negative 2x. And then I got to get the x by itself, so it's being multiplied technically by negative 2. So I have to divide by negative 2. And then negative 2 over negative 2 is 1. So I'm left with x, so my x is by itself now. And then all I have to do is take negative 36 divided by negative 2. So a negative divided by a negative is a positive, and then 36 divided by 2 ends up being 18. So x would be 18. And then if they actually asked you what the actual degree measures of these angles were, remember you just take that 18 and you plug it in for x. Okay. Now this problem didn't ask you for that, but you may have problems that do ask you. So just don't forget to go back and plug it in. All right. So let's do some more. What if they give you a problem like this? Well, notice you got a triangle. They're showing you that two sides are equal, so that means it's isosceles. Okay, so you can use what you know about isosceles triangles. So, well, we have to find this degree measure right here. Well, okay, think about what you know. You know that the base angles are equal. So the base angles here, notice the angles that are opposite of the congruent sides are actually x is a base angle, and then that angle right there that's not marked is a base angle. So we know that these two are equal, but notice they don't give us information about those angles. They give us information about this angle up here. So you're going to have to kind of think through it. So if they give you this angle, well, think about what you know, okay? You know that all the angles in a triangle have to add to equal 180. Okay, you know that these two have to be the same. So you could kind of, if you wanted to think of this, this would be the same as whatever that is. So you could put an x right there if you wanted to. So think about it. Think about kind of what we did up here. Remember how we kind of added those and then subtracted it from 180 to figure out what's left? You could kind of work backwards from that. So you could subtract this one from 180 and see what's left for these if you wanted to. So like if you did that, it'd be 180 minus 80. And you end up getting 100. So that's how many degrees are left over for both of them. And then if you kind of realize, oh, they have to be the same, well, if they have to be the same, then you just split it in half. So you just divide by 2, and you will figure out what those angles are. And so if we divide by 2, we get 50. So both of these angles would end up being 50 degrees. So x would be 50. Okay, so sometimes you kind of have to reason using your theorems. All right, let's do another one. This one. All right, well, look at what you got. You got an isosceles triangle, so you know those base angles are going to be equal. So what are the angles that are opposite of these sides? So notice the angle that's opposite of this one would be angle B. So that one's going to be congruent to, well, what angle is opposite of this side? So if you go directly across, it would be angle C. So you know that this angle is going to be equal to that one. Okay, so like if you wanted to mark it like you did the other one, this would be the exact same as that. So that would also be, I know it looks like a mess, but the 4x plus 6. Okay, and then you have to actually, in this one, they're not actually asking you for x, but they're asking you what's the actual measure of these angles. Well, notice they all have an x in them, so you will have to find x. Okay, so how do we use this information to help us find x and then in turn find the measure of the angles? Well, okay, well, we used what we knew about isosceles triangles. What else do we know? Well, we know that if we add all these up, it should equal 180. And so that's actually what we're going to do is we're going to take each one of these, we're going to add them, and then we're going to set it equal to 180. So we're going to have to set up another equation here. So you take each angle. So I'm going to start with this one. So 20x plus the next angle, 4x plus 6. So that one right there, plus, got to include all of them. The last one is actually the same thing, 4x plus 6. And when I add them all up, it should equal 180 degrees. I'm going to squeeze that in there, all right? So we have an equation where we've added each of the angles up and equaled it 180. Now we just have to solve. So we combine like terms. So we got 20x, the 4x, and then the 4x. Those are all like terms. So when I combine those, I get 28x. And then my constants, I got 6 and 6. So when I add those, I get a positive 12. And then I'm just going to bring down the rest of my equation. And then I just have to finish solving. So to finish solving, I'm going to have to subtract 12 to both sides. So my 28x comes down. And then when I take 180 minus 12, I get 168. And then from there, well, I'm multiplying by 28. So I've got to divide by 28. And then x would be whatever that, or 168 divided by 28 is, which is 6. Okay, so that's not what they were asking me for, but that will help me find my answer. Because remember, now all you have to do to find each angle is go back and plug that x in to these equations. So if I come back and plug it in here to find angle A, I take 20 times 6. And so that gives me 120. So that's the measure of angle A, is 120 degrees. And then to find angle C, I'm going to take this, I'm going to rewrite it, and whenever I get to x, I'm going to plug in, well, I got 6 for x, so I plugged in my 6 right there. So then I've got to simplify that. So 4 times 6 is 24, and then if I add 6, I get 30. So the measure of angle C is 30 degrees. And now if you think about it, this is the exact same thing we just did, or you can realize these have the same measure. So angle B would also be 30 degrees. And then you could check it. These should add to be 180. And notice 120 plus 30 is 150. If I add another 30, I get 180. So I know I've done it correctly. All right. So that's how you set up an equation. All right. What if you had something like this? Well, this is actually kind of the reverse of the theorem we've been talking about. If you see a triangle and they tell you that two of the angles are equal, then you actually also know that the sides that are opposite those angles will be equal. So if they give you a picture like this, then you know the side that's opposite of this angle would be equal to the side that's opposite of that one, because the angles are equal. So this is a little different problem, but you can actually set it up to find x now, because you know that this is equal to that. So you take that, you put in equals, and then you put the other one. If they're equal, you put in equals between them, and then you solve. So to solve this one, solve it like an equation. I've got to get x by itself. So notice I'm going to subtract my 2 first, so I can start getting x by itself. So these will go away. 12 minus 2 is 10, and then my 5x comes down. And then from there, I've got to divide by 5, because I'm multiplying x by 5, and I want the x by itself. So when I do that, it'll get rid of the 5. And then when I take 10 divided by 5, I get 2. So x is equal to 2. All right? So that's kind of how you use that theorem in reverse. Okay? So then the last one. All right? This one, they're asking you to find this angle right here and this angle right here. So look at what you've got. You got a couple things going on. You've got like this little triangle right here. So kind of look at the triangle separately for the moment. Okay. You've got this triangle right here. And then you actually have the big triangle if you needed it, okay? So what we're going to do when they give you a problem like this, you actually want to go ahead and start finding whatever you can find, because not all the time you're going to be able to find directly what they're asking you for. So what I'm going to do is I'm going to start looking and seeing what I know, okay? So I'm actually, since they tell me this angle right here, I'm going to start in this triangle. And I notice that it's a isosceles triangle. So I'm going to look for my base angles. Well, this angle is across from that. and this angle is across from the side that's congruent to it. So I know that these two angles are the same. So I know right off the bat that that angle right there is 60 degrees. Okay, so that gets me started. And then I can actually realize, okay, all three of these angles are in this triangle right here. And I know all the angles have to add to be 180. So I could take these and add them up. So 60 plus 60 is 120, and then I could subtract it from 180, and that'll tell me what this angle is. So 120 from 180 gives me 60. So this actually ends up being what's called an equiangular triangle because all the angles are equal, even though it doesn't look like it. They are, okay? So where do we go from here? Well, we have to somehow find y. Okay, so this actually requires you to remember another theorem. If you look at this angle right here, and then this angle over here, if you kind of put them together, they form that line right there. So they will add to be 180. So what you're going to actually have to do first is find this angle. So this and this have to add to be 180. So if you take 180 minus that 60, you'll figure out this angle, which ends up being 120 degrees because they form that line, okay? Now that actually helps you to be able to find y. Because now you can look at this triangle and you can think about, okay, what do I know about this triangle? Well, it's also an isosceles triangle. And if I look at the angles that are opposite of those congruent sides, I know that this angle and this little angle have to be the same, okay? So these are the same. Well, kind of like this problem that we did up here to find what these angles were down here, we do the same thing. If I know that all these have to add to be 180, if I subtract that from 180, so 180 minus 120, I get 60. That's the amount of degrees that's left over for both of these angles. So to find what one of them is since they're supposed to be the same, you divide by 2, and that gives you what one of these angles are. So this angle would be 30, and then this one over here just happens to be 30 as well because they're equal. So that is angle y. It's 30 degrees.